Muy buenas tardes, good evening, welcome to the YouTube channel of Instituto Cervantes, Manchester and Leeds. Es un inmenso placer de nuevo tenernos aquí para la segunda charla del 2022 de la serie sobre bilingüismo. Thank you for being with us in the second talk about the series of bilingualism, on which we try to analyze, with the help of the curation of Dr. Julio Villagarcía, the implications of bilingualism and the so many advantages that it means for everybody. Today, we will have a lecture from the Dr. Christos Pliatsikas, who will speak about the effects of bilingualism in the brain structure. As I said, this series is designed to show and to share with you the advantages of bilingualism, but at the same time to try to explain the many challenges that this means for everybody. There were some old ideas about bilingualism, especially when we think about children's education, and those wrong ideas it meant that for a long time, we in some areas, in some countries, the educational system stressed the importance of just keep one language as a means of not to get confused or not confusing the children. What has been shown by the experience and that the most recent analysis about bilingualism is just the contrary. When we are exposed to different languages from the very beginning, from the early childhood, even when you are in the womb of the mother, that was the subject of the first talk we have this year, is something that improves your capacity of analysis, your facility to learn not only languages but many other things. And as I said, this is the aim of this series, to share with you the richness of diversity and bilingualism. But before I give the floor to Professor Villagarcía, I would like to introduce him for those who don't know yet him. Dr. Julio Villagarcía is currently a senior lecturer in Spanish linguistics and syntax in the Department of Linguistics and English in Language at the University of Manchester. He is also currently Maria Zambrano Senior Research at his alma mater, the University of Oviedo. And in the course of his PhD at the University of Connecticut, was trained as a theoretical syntactician and also as a language acquisitionist, working especially with the framework of minimalism. His current interests lie in the areas of Spanish Romance and English linguistics, and other interests include child language acquisition, bilingualism, the application. Sorry, can you turn off the microphones, please? The child language acquisition, bilingualism, and the application of theoretical linguistics in research to foreign second language pedagogy. So thank you very much, Julio. Thank you, Dr. Christos Pliatsikas, for accepting our invitation. For Instituto Cervantes, it's a great honor to have you tonight. And without further ado, I give the floor, te paso la palabra a Julio. Muchísimas gracias y seguro que vamos a disfrutar mucho de la charla.
Thank you very much, Pedro. Muchísimas gracias. Hello from Barcelona. I'm not in Manchester. I'm not in Asturias today. It's a real honor to be here in the third session, the third talk of the series. And thank you again for that introduction. And thank you, Christos, for being here today. It's really a great honor to introduce Dr. Pliatsikas. And the title of the talk is The Effects of Bilingualism on Brain Structure. We are actually about to listen to one of the most prominent researchers in the area of experience-based neuroplasticity, in particular, the effects of bi- or multilingualism on both brain structure and function. Dr. Pliatsikas, Christos Pliatsikas, holds a Bachelor of Science in Psychology from Plantin University in Athens, Greece, a Master of Science in Clinical Neurosciences from the Institute of Neurology at University College London, as well as a PhD in Psycholinguistics/Neurolinguistics from the School of Psychology and Clinical Language Sciences at the University of Reading. This was completed in 2010. Dr. Pliatsikas has published numerous articles in premier journals, and he has actually collaborated with a vast number of renowned scholars in the field. His work has been widely cited, as you can imagine. In addition, Christos is currently an associate professor there at the University of Reading and is the director of the Bilingualism in the Brain Lab, also at Reading. You may wonder which questions drive Christos' research. We are all interested in the relationship between speaking multiple languages and the brain, how that's represented in the brain, and some of us picture different areas of the brain being implicated in language when there's more than one language there. You know, another hypothesis is that it's all in the same area, but more specifically, Christos' research questions include whether first, the brain structure and function as well as cognition are affected by learning additional languages, okay? How these effects are modulated by the individual experiences of the language learner. Third, how these effects interact with typical brain development and aging as well, and what the implications for age or disease-related neurodegeneration may be. And finally, whether there are particular effects on the brain and or cognition that are caused by language situations like diglossia, digraphia, which is the use of two writing systems, as well as by literacy. Other questions include the following. What are the advantages of bilingualism in relation to language processing, general cognition, and also brain function? How are morphology and syntax, the study of the internal structure of words and the study of the the structure arrangement of sentences, respectively, represented and processed in the bilingual brain? Do second language learners achieve native-like morphological and syntactic processing? If so, what's the importance of factors such as linguistic immersion and proficiency? I'm really sure that today's talk will enlighten us in relation to these and other key questions. So we're here to listen to Christos. And without further ado, please join me in welcoming Dr. Pliatsikas. Thank you very much.
Thank you very much. Muchas gracias. It's also an honor for me to be here. I was really looking forward to it. And thank you, Julio, for this comprehensive introduction. I'm not going to cover all these areas today, but I will focus on let's say my current main interest, which is the effects of bilingualism on brain structure today. So let me share my screen. So yeah, as Julio already mentioned, I work at the University of Reading, and we have a group there that that is interested in what speaking two languages does to cognition and to the brain as a result. And the two things obviously are related. So before talking about the brain and its structure, it's good to understand what bilingualism is. And you might be surprised to know that there isn't really a consensus of what constitutes a bilingual. So I have a little quiz for you and a little poll, let's say, and I'm trying to do this talk as interactive as I can, given we are an online setting. This would work better in a classroom, maybe next time. But what I want you to do is use your mobile phones. And then as soon as this progresses, there you go. So you go to this website, menti.com, and use this code when prompted. And you will be faced with 3 questions about your understanding of what a bilingual is. And while you do this, I'll share the other screen where you will see the results of this poll. Right. There seems to be a pattern here, which pleases me because this is the expected pattern. I mean, all of these definitions have been used as definitions of a bilingual, starting from the more liberal one, let's say on the left, some with some knowledge of 2 languages, to the more strict one, that someone is born in a bilingual country. And I'm pleased to see none of you thinks that. As I said, there isn't really a consensus, but the definition that different people subscribe to different definitions. The definitions that I subscribe with is the second one, indeed. Someone who can communicate into languages. You don't have to be equally fluent in two languages to communicate in both of them. And if you ask me, I don't know what equally fluent means, to be honest. And certainly you don't need to be born in a bilingual country in order to speak two languages. I was born in Greece. It's not a bilingual country, but I'm able to speak English to you. Let's move to the next question in the interest of time. How do you become a bilingual? Okay, we have almost 50 responses now, and the same, again, a pattern emerges, and that's the expected pattern. People are divided between different definitions of what makes you bilingual, but there seems to be a general consensus that you become bilingual when you use two languages most of your time. So this is a usage-based definition. It has nothing to do with when you started learning the language, or whether you are simultaneous bilingual or you start speaking languages right at the start of your life, let's say. Again, I agree with this definition myself, because I like to think that becoming proficient, efficient in using two languages is intricately linked to be able to using them on a regular basis. Let's move on to the third question then. Okay, we're reaching 50 responses again, and I can see there is some skepticism against bilingualism, but the majority of you seem to be quite welcoming to the idea. You think that improves career prospects and it helps children understand different cultures. I agree with those statements. The more negative statements about, whether it makes people struggle at school or whether it confuses children, so on and so forth. There isn't convincing evidence about this, to be honest. And there is some evidence which has been interpreted in the wrong way, if you're asking me. But we can come to that later on in our Q&A. Thank you for this. So it's time to return to the presentation now. Right, okay. So this first set of slides, this poll was only to demonstrate to the definition of bilingualism is a complicated matter, actually. But let's walk through the stages of what makes you bilingual and how you become bilingual. So the most obvious thing for someone that learns languages is that it learns new words, okay? We shouldn't forget that we learn new words for known meanings. In other words, you see this little fairy animal here, which in English is called a cat. If you learn German, for example, you learn a new word for this animal, which is Katze in the case of German. Remember that all the names that we give to images, to pictures, to items, to anything are not objective, are subjective, are conventions. There's no reason why this small animal is called a cat. If it had something to do with the characteristics of this animal, it would be the case that all languages use the same word, right? But each language uses a different label for the same concept. So remember, words are labels that we learn and we apply to known concepts. But it's not just that. So this is learning of vocabulary, as we call it, right? But it's not just that we do. There are other things that you learn when you start learning a language. For example, I'm pretty sure you all know who this person is. That's Julia Roberts. And her name is obviously Julia. But that's the way to read this name in English. If you try to read the same name in German, you would read Julia. And if you try to read the same name in Spanish, as well, this is the Instituto Cervantes, you know that. The same name is read Julia. So what happens here? You learn different sounds for the same letter. So when you learn a new language, you don't only just learn labels for meanings, but you also learn new sounds for letters that you already know. And this obviously applies to pairs of languages that use the same alphabet. So English speakers learning German or learning Spanish, right? So this is an example of learning phonology of a new language. But it doesn't stop there. What happens in cases where you learn languages that have different scripts? We tend to forget, us here in Britain or in Spanish-speaking countries, so on and so forth, all these countries that use languages that use the Latin alphabet, that there are plenty of other scripts available in other languages. So if you happen to learn a language that uses a different script, you need to learn that script, and you need to learn those symbols, and you need to be able to attach sounds to those symbols. And these are some examples, right? Starting from the top, the Arabic script, the Greek script, I can tell you this is read Gata, Georgian, Chinese Mandarin, Thai, Cyrillic, and that's Russian language in this case, and Hebrew. So if you have to learn a language that uses this script, there's another layer, there's another level of learning that you need to do, and that's the learning of orthography, let's say. And it doesn't stop there. Languages have rules that govern a lot of things. So in this case, we're talking about rules that govern the order of the words in each language. So the first picture in English, you would say it shows a brown dog. So you have dog, which is the animal you're describing. And you have this word brown, which we call an adjective in linguistics, which describes your animal. In French, I will apologize for my accent in French already. The same picture will be read un chien brun, meaning that the animal itself comes before the adjective, before the word that describes the animal. So this is a good example of the two languages have a different word order rule. Okay, so in English, the adjective comes before the noun, as it's called, whereas in French it comes later. Similarly, if you compare English to German, you would describe this image, you would say, I have eaten the apple. So that's your verb. That's the word that describes the action you just done. In German, this would be, ich habe den Apfel gegessen. And the verb, the action, goes at the very end of the sentence. So the word rule in English is that the verb is followed by the object, the item that receives the action. In German, the object comes before the verb. So that's another thing that you need to learn when you learn another language, right? Different rules. And this is an example of syntactic rule, and syntax is part of grammar. So you learn all these things, obviously, but the most important thing to remember is that all this information is active and it is competing at any time. This is my famous slide of the fighting Julius. So it's not that you speak one language and you switch off the other. We have very, very, very good evidence to show that all of the languages that you speak, that you're proficient at, are active at any time. And all the subcomponents of those languages that we saw before, right? Vocabulary, phonology, orthography, syntax, so on and so forth. They all remain active and they all try to be expressed, so to speak. So there's competition between the languages that you speak. How do we know this? A simple way of knowing that is if one of you unmuted now and spoke to me in Greek, I would be able to respond straight away in Greek. It's not that I've switched my Greek off and I can only speak English. So if I would converse with a English-Greek bilingual like myself, I would be able to switch between languages effortlessly, a process that we call code switching in linguistics. I describe these processes as a tug of war, right? So you have both languages being active, both languages competing for production, and the bilingual should always be able to use the target language, the language that is appropriate to a given context. In other words, if I started speaking Greek to you, we wouldn't go anywhere, right? So I need to actively suppress my Greek, which is fighting, which is trying to be produced at this time. This is obviously a matter of context, a matter of where you find yourself at, right? So I'll use myself again as an example. I live in the UK for, I forgot how many years now, 18, but I still have a Greek partner, I have Greek friends. So here in the UK, I mean, so I am using both my Greek and my English, possibly in different contexts, but I use, right? But I use it. I use them both. So Greek for, at home or for social gatherings, so on and so forth, and also English at work. I couldn't teach in Greek, obviously. So this keeps this competition active. This keeps these languages very, very active. However, if I decided to move to Greece tomorrow, one of these domains will go, right? Work will go, will not be in English anymore. If I decided to start working at a Greek university, I would be asked to teach in Greek. So I would reduce my opportunities to use my second language. And over time, my second language would weaken, would not fight as hard as it did for production. And over time, I may start forgetting words. I will not forget the rules of the languages that easily, but it's more possible that I will start forgetting the words of the language. So it is a case of use it or lose it. So the question is, why do we care about all these things, and where does the brain come in? You may have gathered that all this process of these fighting languages, the competition, using one while suppressing the other, so on and so forth, that is a mentally very challenging situation, right, for the bilingual. And it's a challenging situation that is not faced by a monolingual who only has one language to use, obviously. So the question is, this possibly long-term challenging situation, does it have effects on our general cognition? It does have any effects on the brain? And where does this come from? I'm pretty sure you're familiar with this literature that says that doing crosswords or Sudoku, or even doing gardening or having a hobby, so on and so forth, trains your brain or keeps your brain younger or keeps it active, whatever you name it. And especially that all these things are good for older age. Well, this might be the case, although there is some controversy in that field. The problem with all these activities, it is that they are leisure activities, right? That there are things that you can choose to do or choose not to do. You can choose to start doing Sudoku and then you may be bored in a month's time. You can choose to start doing your gardening and may you find yourself, drawn to something different, right? So fine, okay, these things may challenge your cognition, but then, as I said, they're leisure activities. You have the option of not doing them. So would this argument of brain training, as it's called, apply to bilingualism? Bilingualism is a challenging situation, but it's not an optional situation, especially if you live in a country in which you use both of your languages, right? I don't have the liberty of not using my English. I need to use English to work, okay? So this is not something you do as a leisure. This is something you do because you have to do. So a lot of researchers have been trying to see how bilingualism affects the brain. Well, the cognition to begin with, but also the brain, which is, let's say, the underlying mechanism under the hood. And there is some evidence to suggest this. Sorry, it was a message. We'll respond to this later. I did something with the chat. Apologies. Okay, yeah. So what we will do now, again, this would work better if it was in a classroom, but that's fine. What you will see now is a series of letters. On different screens, you will just see a collection of letters. And there's a very simple task. You need to say aloud the color of these letters, right? So you don't need to unmute or anything, just do it at your pace. All I want you to do is say out the color of this letter. There are some crosses in between to keep you focused. You can ignore those, okay? So let's do that. Right, okay, that was a very non-scientific experiment, but hopefully will help me prove the point. So if I were to ask you which of these conditions, as we call them, was the hardest, you would probably tell me this condition here. Blue written in red ink, let's call it, right? So think about what this experiment is. You have two sources of information. You have the actual color of the letters that you need to read out. That's what I asked you to do. But also some of these words carry some meaning or semantics, as we call them. This obviously does not apply to the first condition up here, which is a series of X's. So you just say red. The second condition is the word red written in red color. So now you have two sources of information. You were asked practically to ignore what the word says, just say the color of the word, okay? But in this case, you have two sources of information that agree with each other. So you have red, the meaning, plus the color red. So reading this would be, reading the second condition would be faster than reading the first condition. The third condition is the most difficult one, simply because you have two sources of information, again, the meaning of the word and the color of the word, which in this case do not agree, right? So there's a conflict. So in this case, you will have to suppress this very salient cue, very obvious cue, the actual word, and read out the color of this word, right? And this would have caused you to be a bit slower in this condition. I'm pretty sure it was. So this is what we call an incongruent condition in this type of task. By the way, this is a real task and very well studied task in psychology called the Stroop task. But what is important is that we have a lot of evidence to say that bilinguals are faster in saying red when they see this word, the word blue, than monolinguals are. What does that mean? That bilinguals are more efficient in resolving this conflict between the two contradicting sources of information, or bilinguals are very efficient in suppressing the meaning of the word in order to say out the color of the word compared to monolinguals. Why is that? Well, the theory says that if you've spent years and years and years dealing with these two fighting languages, and in each and every case, you have to pick the one that matches your context and suppress the other, over time, you become very efficient in this task, right? In suppressing irrelevant information. And this shows in other types of tasks that have nothing to do with switching between languages. So, does bilingualism train your mind? We're still talking about the mind. We haven't started talking about the brain yet. We will in a second. It appears so. And the theory, as I said, is because bilingualism is a long-term experience in choosing between alternatives. So let's move on to the brain, which is the main topic of this talk. I know we're over half of the talk by now. And let me introduce you to my own brain, which thankfully looks typical. I have the full set. I'm very happy. So this is one of the scans that we acquire in our MRI scanner here in Reading, and we use those scans to study brain morphology, the structure of the brain. You will see that the brain is darker on the outside, this lining here, and whiter on the inside. We call the outside the gray matter and the inside the white matter. I won't go into too many details about the differences. But I'm using this to tell you that, to show you that, well, obviously the brain has very defined structures. And we know there's some functional specialization in the brain. And we also know that learning and maintaining a new skill affects both the function and the structure of those regions of the brain that undertake this skill. Okay. And I will focus on structure today, as I said. So how do we know that from other types of skill acquisition? So, for example, there is research on basketball players that shows that basketball players have bigger cerebellums, this structure down here on the left, which we know is important for fine movement and balance, which you would agree are very important for athletes and also are more developed in athletes. So this skill acquisition is expressed by increases in the volume of this part of the brain that undertakes that skill. Similarly, there is evidence to show that taxi drivers have bigger hippocampus on both sides of the brain. So the hippocampus is a structure that does many, many things. Among those, it is very important for navigational skills. And you would agree with me that navigation is very important for taxi driver, more important than people that are not taxi drivers or people that do not drive at all. So taxi drivers have been shown to have bigger hippocampi than non-taxi drivers. Similarly, the study on musicians to show that they have a bigger Hessel's gyrus. This is this part of the brain around here, which we know is very important to acoustic perception and perception of tone. And again, you would agree that these skills are more developed in musicians. So why then wouldn't we find similar effects on those parts of the brain that deal with this very, very challenging skill of acquiring a language on top of the language that we already have, but also with dealing with a conflict between the two languages. And indeed, we have found a lot of evidence that this is the case. So what you see in this graph, it's a summary of those parts of the brain that are involved in language acquisition and language control. And you will see there are quite a lot of them, right? Not all of them do the same thing. So you have regions towards the back and top of the brain, let's say, that are very important for the acquisition of vocabulary. You have regions at the front of the brain and deep inside the brain that are very important for language control, so on and so forth. But what we have found is that all of these regions reshape, change in volume and in shape in bilinguals compared to monolinguals. So now it will become a bit more academic. I will show you some evidence from the experiments we have been running in my lab, some of the most recent ones, actually. In this one that was published 2019, we showed, well, first of all, that bilingualism affects the structure of the caudal nucleus. The caudal nucleus is an important part of the brain. You will see here is like in the middle of the brain. And that's very important for language control and cognitive control in general. So the caudate would be responsible for you controlling whether to say blue or red, as we did in the previous experiment. So we have found that bilingualism affects the volume and the structure of the caudate nucleus. But importantly, we have found that different bilingual experiences and the amount of those bilingual experiences affects the structure in a different way. So what you see here in the first row, the caudate nucleus in green, and then what you see in red is restructuring, expansion, in this case, of the caudate nucleus as part of using your two languages in social interactions. That is, the more you use it, the more it expands. In the second row, ignore the other structures, just focus on the caudate, this time in light blue. You will see several effects. They're not very easy to see in this image, I admit. And then in this case, you have, sorry, that's the yellow, not the light blue, I'm sorry. What you have is both extractions and contractions as a function of being immersed in a bilingual environment. So the more years you spend in a bilingual environment, you have expansions on one side and contractions on the other side. So this gives us some restructuring of the caudate nucleus, right? So we can measure how active a bilingual you are, and we can see how it affects your brain dynamically. So I gathered all this information, older information, and some from our own lab, and I came up with a theory which I call the dynamic restructuring model. So according to this, brain regions that are related to language acquisition and language control increase in size when a new language is learned. And why is that? The brain forms new connections. Every time you learn something new, the brain forms new connections. And these new connections are tried and tested to see which ones can accommodate this new skill. These new connections mean that you have local increases in size, right? Because you have more tissue, more connectivity. And that explains all the effects that we saw in the taxi drivers, in the musicians, so on and so forth. How big those effects are, when they happen, it depends on the brain regions that are affected and the skill that is acquired. So when you start learning vocabulary, it's more likely you see increases in the hippocampus and all those parts of the brain that are involved in language acquisition. When you know enough of the language and you have to control alternatives, then you will find those effects in the caudate nucleus and other parts of the brain that deal with language control. So you have those increases, but the brain cannot grow forever, right? There are physical constraints. We have a skull that can host, which cannot really expand to host more brain tissue. So what happens with increased practice? As we said, the brain has created all these networks in order to find the more efficient ones. And then it does find the efficient ones. It does find the networks that help language control, let's say. But in the process, it will have created other networks that are not useful anymore or are redundant. In this case, those networks get killed off, practically, get pruned. So it has created a lot of new networks, but at the end, it only keeps the most efficient ones. So this initial increase we found in local volume starts decreasing again. So the local brain volume returns to baseline. And now we have almost returned to the original volume, but now we have some connections which are very, very efficient, all the time used, because now you have to control your language all the time. And there's a good chance that these connections may be more resilient to degeneration. And this is where it becomes really, really important. So why should we care? Okay, so the brain grows and shrinks and grows and shrinks and creates very efficient connections, and they may be resilient. Is there any practical implication? Does it change our lives? Well, it may do. We have already said that bilingualism is a long-term experience that trains the brain, right? I use these, I use trains very liberally in this case. But is it the case that it reinforces the brain? Remember, we talked about these resilient connections. What does that mean? So here is a recent study from my lab, where we looked at the big cohort of bilingual and monolingual children, adolescents, so people from the age of 3 all the way to age 21. And we want to see whether they differed in terms of how thick their the gray matter was, the cortex was. And this can be, you can see this in these graphs down here. So in both cases, on this axis, you see the age of our participants, with the younger ones being 3 years old and the older ones being 21 years old. And on this axis, you see the thickness of our regions of interest. The higher in this axis, the thicker it is, right? And now I have focused on 2 regions, the inferior frontal gyrus pars opercularis and pars orbitalis. Don't worry too much about the actual regions now. And then you have monolinguals in blue and bilinguals in red. The first thing you will see is that there's a drop, right? So as we grow old, the thickness becomes practically less, right? So the cortex becomes thinner. This is a very well-known effect. It's a very well-known developmental effect, right? This is how we develop. There is nothing we can do about this, okay? However, what is important to notice here is that if you look towards the end of these graphs, the 2 lines diverge, and bilinguals are higher than monolinguals in both cases when it comes to these 2 structures, meaning the thinning in bilinguals, yes, it does take place as they grow old, but as they grow older, but it takes place at a slower pace. So they reach the age of 21 and they seem to have more tissue than monolinguals, okay? So this thinning has taken place, but at a different pace. This is important because it means that we have more brain tissue to spare when it comes time, when the time comes to spare tissue. And when is it that the brain spares its tissue? Well, when we age, So this is the most important thing. What happens in older age in bilinguals? So how do you grow old and bilingual? I will introduce two concepts here, two concepts of reserve that are widely used in the aging literature. So people talk about the neural reserve and the cognitive reserve. Neural reserve means that you practically accumulate brain tissue through experience, through challenging situations, so on and so forth. So when you reach the older age, there is this extra tissue that you have to spare. It's what I was talking about earlier on. The cognitive reserve means that you make your connections in the brain efficient enough so you can still be functioning even when you've started losing the tissue, even when the brain starts shrinking, when the connection starts dying. So you have more efficient remaining connections. Both of these concepts are relevant in bilingualism, and we have evidence that bilingualism may do both, actually. So I will focus on neural reserve that you see here on the left, and practically this relates to the neurostructural changes that we have seen so far. We only saw them in brief, but we talked about both gray matter and white matter changes. So this is a newer study that's still submitted for publication, so wish me good luck, with my former student, Michal. And what we did in this case, we tested 110 Czech English bilinguals, and we tested the volume of the coded nucleus again, and how it's predicted by age, and how it's predicted by the bilingual experiences. This is a three-dimensional graph, so I will explain its axis separately. So what you see here at the front, marked as LSBQ, is a score of the bilingual experience. I won't go into details, but this side means the right side means there's practically no bilingual experience, and the left side means there's a lot of bilingual experience. On this axis, you see again the volume of the coded nucleus. Okay, so zero, well, it's not zero, very small at the bottom and very big at the top. And then on this axis, you see people's age. So in this particular graph, our younger participants aged around 18 are at the back, and our older participants are at the very, very front, aged about 53. So let's start with this slope here. What does it tell us? Well, age against volume, that younger people have higher volumes than older people of the coded. Typical developmental effect. The coded will grow smaller as we age, right? We know there's nothing we can do about this. However, what does this slope here tell us? That people, 53-year-olds, right at the front, that are practically monolinguals with no experience, have much smaller codeds than 53-year-olds that are bilinguals, that are active bilinguals, which you can find up here. Okay, and this is what really matters, because we see that functionally monolingual people that do not switch between languages, have less brain tissue than people of the same age that are very experienced in switching between languages. We also have this nice fold here, which tells us that with experience, the coded increases and increases and increases and increases. It reaches a point where it starts decreasing again. This is what I talked about. Now it starts pruning. Now it starts keeping only the active, the efficient connections, and the useless ones get pruned. Okay. I haven't spoken about the young ones, which are at the back. They remain high. There's a similar effect for them. The more experienced ones have bigger coded nuclei. But what I want to focus here is something that you may have noticed already. That is, remember, this part of the graph is 53-year-old bilinguals with the volume of the coded up around here. This part of the graph is 18-year-old monolinguals with the volume up until here. And you could see yourselves that the volume for the two groups is comparable. I don't have the stats to back this up for you, but you could say that very experienced 53-year-old bilinguals have similar volume of their coded as 18-year-old monolinguals, which is a fantastic result if it is true, right? I'm just being very cautious in over-interpreting that finding. We have also looked at older people, healthy older bilinguals. In a very recent study, we compared old immersed bilinguals, so mean age 62, I think they were between 55 and 75, so more or less. And all of them were living in the UK at that time, but were non-native speakers of English. They were bilingual, active bilinguals. And we found that older immersed bilinguals, our group, had larger hippocampi than monolinguals that were matched on age. Again, the hippocampus, I may have said that already, is very, very important for the acquisition of new words. And you always acquire new words in your second language. The other thing we found is we did something similar to the graph that I showed you. This is a two-dimensional graph. And you will see, well, on this axis, again, we have this bilingualism composite score. In this case, the left means functionally monolingual, and the right means very, very active bilingual. And on this axis, we have the volumes of the hippocampi. And the left is red and the blue is right. So you will see that for both the left and the right hippocampus, bilingualism score, so the experience of active bilingualism positively predicts the volume. In other words, the more active you are, the bigger your hippocampus is. So we have evidence from young bilinguals and we have evidence from old bilinguals as well, right? So what about the other concept? And I'm reaching the end of this talk. And I won't go into details about this because it's a very long conversation, really. But what is branded here in your compensation is similar to the concept of cognitive reserve. In other words, bilingualism trains your connections to be very, very efficient, which means that when the brain starts shrinking, when neurons, the building blocks of the brain, start dying, you're still able to use whatever is left and be cognitively healthy, or at least functional. There is some evidence that bilingualism does that, especially on patients with Alzheimer's disease, but it's very, very limited, simply because it's difficult to recruit bilinguals with Alzheimer's, and also it's difficult to test patients with Alzheimer's in general. But the pattern that we have suggests there is cognitive reserve in bilinguals with Alzheimer's disease. And how does this express? So imagine that here on this picture on the right, you have a healthy brain, monolingual brain that is healthy. And on the left, you have a monolingual brain which is healthy. And on the right, you have a bilingual brain which has Alzheimer's. You could see yourselves that the brain with Alzheimer's has shrunk significantly. And to give you an example of the structure I was talking about, this is the hippocampus of the healthy brain, and this is the hippocampus of the brain with Alzheimer's. So there's a good chance that these two individuals have the same cognitive abilities, same cognitive skills, because the bilingual on the right may have suffered substantial shrinkage of the brain, but due to the cognitive reserve, what's left of the brain allows this person to be functional still. But as I said, I won't spend too much time on this evidence because it remains limited and controversial. So the clinical implications of bilingualism, which comes under this limited and controversial literature, is that bilinguals with Alzheimer's show symptoms of dementia 4 to 5 years later than monolinguals with Alzheimer. Note, this does not mean that bilingualism cures Alzheimer's, right? This is not about that. It's about staying at least cognitively functional for longer. There is some newer evidence that shows that stroke survivors that are bilinguals recover more successfully from bilingualism, so they're more responsive to therapy, for example, and they suffer less severe aphasia post-stroke, so that's speech difficulties. The question is, what about other neurodegenerative conditions? And we wanted to investigate this, and in this paper, we gathered evidence from a series of papers looking at bilinguals with Parkinson's disease, Huntington's disease, and multiple sclerosis, which is something like 6 or 7 studies in all, very, very small literature. But we have found that there is the same trend even in these diseases, that bilingualism may cause these neural and cognitive reserves that we talked about, so it may be a more generalized protective factor in different types of progressive neurodegeneration. This is something that's very promising, but again, it requires much more research. And if recruiting patients with Alzheimer's disease is difficult, recruiting patients with multiple sclerosis or Huntington's who are also bilingual is extremely difficult, but we are trying. And I'm almost done. I only have a take-home message to give. Learn languages and use them. Be active bilinguals, right? Use every opportunity to use the languages that you know, because it is good for you. It may prove good in the older age. And with this, I'd like to thank you for your attention and thank you for coming here in such a hot day.
Thank you, Christos. A lot of food for thought here. So I think we're still processing all the information that you gave to us in an extremely accessible way. So thank you for popularizing all these so well, while still being faithful to the complexity, right, and the rigor that characterize this phenomenon. All right, so we have a number of questions, especially in the chat, and Carlos will send me questions from YouTube, if any. So I will follow, the chronological order for fairness. There is one question which reads as follows, Christos. For me, the advantage of bilingualism is that you come to realize that there is more than one correct way to say view things. The monoglot, however, does not have this advantage. Do you agree?
Yeah, that's interesting. I would agree in the sense that learning languages also helps you learn different cultures and seeing how different cultures understand the world differently, for example, right? I mean, I don't know how that expresses to the brain, but definitely. One of my favorite examples is that not all languages have a word for the color blue. Right? In some languages, blue is not a separate color, is a shade of green or something. And thinking about it, for us whose languages do have color blue, is mind-blowing. How is not a separate color? But this is a good example of helping you understand how other people think, that there are different ways to say, to view things. To the extent that you learn cultures, absolutely, yeah.
Sorry, another question literally reads as follows. What's the average number of networks for a bilingual? Can it shrink? What about the reduced link with Alzheimer?
I don't think there's any way of saying how many networks there are. I mean, there's no way of counting the neurons of the brain, let alone how the neurons connect to each other and create a network. I'm sorry about that. Whether it can shrink, I don't know if that question came before I mentioned that the brain is shrinking. And well, yeah, the brain does shrink as we age. As I said, there's no question about this. And in Alzheimer's, another source of neurodegeneration, it shrinks faster. I mean, it's more profound. But as I said, there's a good chance that bilinguals are able to utilize the surviving connections more efficiently, bilinguals with Alzheimer's. That's why they don't show the symptoms of Alzheimer as soon as monolinguals do. It doesn't mean they don't suffer from Alzheimer. It is that the symptoms appear later. Yeah.
There's a delay, right?
Mm-hmm.
Another question is, does bilingual restructuring of the brain mean that some other areas are sacrificed?
No.
I mean, does it go in?
No, there's no evidence to show this. Brain areas don't get sacrificed easily unless there's brain trauma, let's say. It's more about how the brain chooses to invest its energy sources, so on and so forth. But it's not that, you increase something, but you have to lose something else. No, it doesn't work like this.
And as you said earlier, some of the questions came on this, on the spur of the moment. So they were related to something you were saying. So the use of pronouns there, demonstratives, might be a bit confusing. But one question is the following: does this mean that the areas deleted, are from the same brain area, or could it be that you lose neural pathways from other skills not used as much?
Okay. You lose neural pathways. I mean, creating new pathways in order to accommodate bilingualism does not necessarily mean you do it on the expense of something else, right? So think about, playing an instrument, play a piano when you're young, and then you stop it when you're an adult, and then you lose the skill, right? This probably means that there was some network that you had created, which was efficient at the time, but then you stopped utilizing it. So it became redundant. We have the same evidence from bilingualism as well. So we have at least 1 or 2 studies that show that bilinguals that stop using the languages, so these were longitudinal studies. So there was these increases in brain structure, and you have it within a year. And then they were scanned again after another year of not using the language, and they had lost all this extra tissue simply because they were not active users of 2 languages. So no, you don't delete areas from the brain, but the neural pathways need to be kept active to stay there. Otherwise, they become redundant. And the other thing you need to know is that the brain kills off networks simply because networks consume energy to keep alive. And the brain doesn't like to do this, right? That's why it keeps the more efficient ones.
Mm-hmm. Interesting. So it's a little bit like when you empty your hard drive, right? When the space is filling up to a certain extent, but
yes, it's a good analogy. Yes, exactly.
Excellent. What does the volume of the coded nucleus correlate with beyond bilingualism itself?
The coded nucleus is a very important structure for cognitive control in general, right? So it's this part of the brain that gates your responses and say, oh, that's the appropriate thing to do, that's the non-appropriate thing to do, pretty much irrespective of the task that you're faced with. That's why I said that even when you're trying to name those words, it's a coded nucleus that comes in and says, oh, this is red, don't say blue because you read it, right? So it's a very important structure for cognitive control in general. And language control is not independent from cognitive control, obviously. That's why the coded is also involved in language control.
What about when you speak more than 2 languages? Which areas are lost, and are the challenges bigger in acquiring the 3rd language?
The $1,000,000 question: what happens with multilingualism? So when it comes to brain restructuring multilingualism, the evidence is much more limited. But we have some evidence that shows that if you're a seasoned professional bilingual and then you start to learn a 3rd language, the whole cycle of increases and decreases starts again, right? So then the brain again tries to find networks now to accommodate this even more challenging skill of using 3 languages. And again, the areas of the brain that are affected are not different to those affected for bilingualism, because it's not the case that I store my Greek here and my English here, and now that I'm learning Spanish, I'll store it here. No, we have areas that specialize in vocabulary learning or syntax learning, and also in language control. So if you keep on learning more languages, you will still tap on the same regions of the brain, and there will be some restructuring. But the problem is that there isn't a lot of studies around. There aren't a lot of studies around on multilinguals. And if you have trouble defining bilingual, try defining multilingual. This is a very, very complicated task.
Good language learners perhaps have bigger memory capacity and bigger capacities to pay attention to things on these regions in the brain, and these are regions in the brain. Do these regions increase too? Is there any evidence to that effect?
Sorry, you broke up a bit, so I didn't catch all of it.
Sorry about that.
No, it's probably my connection, sorry. Yep.
No worries,
yep.
It might be mine. I'll rewind. Good language learners perhaps have bigger memory capacity and bigger capacities to pay attention to things, and these are regions in the brain. Do these regions increase as well?
Bigger memories. Well, I wouldn't know how to measure bigger memories, to be honest, but regions related to acquisition of knowledge, which is encoding memories, and also storing memories, do seem to restructure in bilingualism, right? So that's the hippocampus, and there are certain parts of the temporal lobes. But there are different types of memories, right? So it's memory of knowing words, but memory of applying linguistic rules. And there is some specialization in brain areas. So whether it's, let's say, extrapolate to general memory skills, there is some limited evidence, and I think there's evidence in older adults that their long-term memory may be slightly better compared to monolinguals, and this may also relate to this extra volume they have in those memory areas. Julio, I have a direct message that you probably don't see.
Okay, we'll deal with it.
Okay, yeah,
you can leave it for the end, and you yourself will read it out loud if you want. So, Christos, have you looked at the effects of when the person became bilingual, namely native or early bilinguals versus late or adult bilingual?
Okay, that's the message that I have in private as well.
Okay.
So the effects of language learning on the brain for late versus early. This is what the literature started looking at, but the pattern of results were very confusing because you would find effects in late learners only, but not in early learners. And that caused this confusion that I tried to address with my model, simply because early learners started much earlier. So if they were tested at the age of 25, all this renormalization would have happened. Whereas late learners start later, so you catch them at a different window. You catch them at the place where you still have some areas of the brain bigger compared to monolinguals. Early learners tend to be more efficient as well, and that explains the fact that you don't see a lot of increases in the cortex when you look at early learners. So I prefer not to do this distinction between early and late, because this does not take into account whether these people are active bilinguals or not.
Actually, the next question is in that connection. Would you say that those effects are effective just in bilinguals with a constant use of their two languages?
Probably yes, because a lot of, especially the studies looking at cognition, behavior, a lot of the studies that do not find these bilingual benefits look at bilinguals that I would say are quite opportunistically recruited, right? So if you go to a university in Britain and recruit year one undergrads from different countries and recruit them as bilinguals, you have not given them the opportunity to develop those skills, both language learning, but also language control, which is the most important one. So yes, the results from long-term active bilinguals are much more consistent.
Native speakers of Chinese, and to a certain extent Japanese and Korean as well, in addition to their own systems, use different ranges of Chinese characters.
Yeah.
Does bilingualism in those languages change the structures of the brain differently? How does this affect the thinking process? Is there any recent neuro research on the issue?
This goes back to processing different scripts in different languages. And there is some evidence. I don't know if it was between Chinese, Japanese bilingualists, but I think it was Chinese, some sort of Latin alphabet language, I don't remember. But there was some restructuring, and interestingly, it was restructuring those parts of the brain that deal with decoding letters, which is very, very separate to the parts of the brain that do language control, right? So anything that has to do with vision is situated, located towards the back of the brain, and that includes recognition of letters. So in this sort of bilinguals, biliterate bilinguals, there were some restructuring, there were some increases in parts of the brain that learn how to read letters. Yeah, so there is an effect. Whether there's an effect on thought in general recognition, I think this wouldn't be any different to effects that you would find in Spanish English bilinguals, for example, right? But that's a hypothesis now. I don't have any strong evidence to provide.
Regarding multilingualism, it is not unusual that in places like India, for instance, individuals may have to get to use 4 or 5 languages. Do you know of any study from true multilingual people in that area of the world, in that part of the world?
So the important thing is that the interesting thing is that the most convincing evidence we have about the delay of dementia symptoms in bilinguals is actually on multilinguals. So it comes from India. So the studies by people like Suvarna, Ladi, and Thomas Bach have been run in Indian population, simply because in India, it's very, very common. You have bilingualism, multilingualism. And these people were shown to show this delay of the expression of dementia effects. But this is not a brain study. They didn't look at brain structure necessarily. As I said before, there's very limited evidence, but there seems to be some extra processing taking place when you learn more than 2 languages.
Mm-hmm. If neural networks consume a lot of energy, do bilinguals/multilinguals naturally consume more energy than monolinguals, or is the brain quick to adjust if switching between languages is consistent?
Well, whether they consume more energy, I wouldn't know.
Estaba yendo lo del bilingüismo.
Sorry?
Just there was somebody who.
Okay, sorry, I thought it was for me. Yeah. Consume more energy. I wouldn't know how to measure this, but I know that the brain has its limits, its ideal limits, right? That's why it chooses not to have too many networks lying around. So it will keep the good ones. So yeah, that's how it expresses efficiency, because yeah, create all these networks, but yeah, a lot is happening, so it needs to deal with it. So whether overall is more energy that's consumed, I don't have the methods to study this.
Mm-hmm. I don't see any other questions. I see a couple of comments, but no questions on YouTube either. But I encourage anyone to just unmute themselves, introduce themselves to the speaker, and ask the questions if you'd like to. Give you a few seconds to do that. I'm very impressed with, I've been interviewing all day, Christos, people for PhD programs, and I'm impressed with how good you are at answering the questions very shortly, very accurately. I'm not comparing you to the PhD candidate, but it's pretty impressive. So congrats on that.
Thank you.
William, please, William Snyder from the University of Connecticut.
Hello.
Yes, Julio and I go way back. I had a question, sort of a follow-up question. I asked the question about volume, so brain volume of the caudate nucleus, and how, whether volume itself is a good predictor of anything independently of bilingualism. So it's helpful that you say, yeah, the caudate is involved in executive control and gating. But I'm wondering if, for example, we were to look at a population of monolinguals and obtain information about volume of caudate nucleus, would it actually predict anything about how those people performed in script tasks or other executive control tasks?
This is the chicken and egg question, because the whole field started the opposite way. So they would look at people's brains and see how morphology would predict behavior. Is exactly what you're describing now. So there is a link, obviously, but the issue, and yeah, caudate volume does predict behavior, not very straightforward ways necessarily, but it's not independent. But the issue is with bilinguals is when people tested bilinguals, measured this volume, and then saw how it predicts behavior, again, didn't take into account where bilinguals were in the cycle, right? Were they very, experienced ones? Were they not very experienced one? That's why it flipped over. But obviously, brain structure does lend to behavior. It does. There is a connection.
So structure, but I'm again sort of pushing on volume surprises me because it's thought that to a large extent you can predict overall volume of the brain just from body size of a particular individual organism, and also whether the organism operates in mostly in 2 dimensions or 3 dimensions, as in the case of aquatic mammals. So at a broad scale, it seems that the big factors in sort of average brain size are not terribly well correlated with cognitive functions, except maybe sort of lower level ones. So that's why I'm a little bit cautious or hesitant. So it's very helpful for me to have.
Absolutely. I mean, I am hesitant with everything. I'm cautious with everything I've presented. But think about the whole brain volumes. Whole brain volumes is a different thing than the volume of specific structures within the brain.
Absolutely.
Because it includes, cerebrospinal fluid and other sort of things. But yeah, I mean, it's good to be cautious with these things. I mean, we don't know everything. We just, researching, I suppose.
Fair enough. Thank you.
I would like to say just congratulations for this wonderful talk. Really impressive.
Thank you very much.
Thank you so much. That reassures us, to me, to everybody. I think that how important it is to promote the learning of languages and to look at the world from different perspectives with different languages. So thank you very much, Christos. Thank you very much, Julio. It has been great, really.
Thank you for the opportunity.